So what do you think is a way, now that we've tested it, what do you think is a way that we could actually try to solve this problem?
We could do a computer simulation.
Okay, computer simulation. Just sketch for me how that simulation would work.
Well, you choose 3 random numbers, or 4 random numbers between 1 and 6.
Uh-huh.
And then you don't use the lowest one.
Okay.
And then you run that a bunch of times. Right, well you find the sum of the highest 3 and then repeat.
Okay, good.
Yeah, I think you can either do it with probability or just running it a bunch of times and seeing what you get.
What do you mean do it with probability?
Well, you could like find what the probability expected value is.
Like the expected value that you would get a certain, like the expected value that you get like 13 for example.
Like how many times you can get each number.
Oh, okay, yeah.
If we count, yeah, I guess.
All the different ways to do it, yeah. And then, all right, that's interesting. Yeah, see, this actually is a surprisingly challenging problem.
Yeah.
Yeah.
What if we did it with just 2 dice, and we just were picking the high? How would you do that instead of 4 dice? So what if we started with 2 dice?
Well, then we can look at it like more probabilistically, and look at like the probability of getting like 4 as your higher number, and then since we need to find the expected value, we can add up all the probabilities of getting each number, and then we can do it like that.
Okay. Do you have any other suggestion for how we might do this with 2 dice?
Yeah, but it's basically the same. Just you look at the probability of the getting each one, and you add up the probabilities.
Okay. So one thing I might do with 2 dice is just make a grid. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. I'm just going to make it quite long. Okay. So down the diagonal, it's 1, 2, 3, 4, 5, 6. And then above the diagonal, this number is always bigger, right?
Mm-hmm.
Yeah.
So it would be 2, 3, 4, 5, 6.
8.
3, 4, 5, 6. 4, 5, 6.
Yeah.
5, 6, 6.
And then it would repeat in sort of the same way.
Yeah, like that. And then we could just add them up. Each one of these is equally likely, right? So those are the 36 cases.
Yeah.
And then we would see what the expected value was. Probably can add these up reasonably quickly, right? Because there's 11 sixes.
66.
9 fives?
2, 3, 4, 5, 6, 7, 8, 9. Yep. So that's 45. How many 4s are there?
Should be 7.
4, 6, 8, 10.
No, because this 5 and this 5 are my row markers.
Alright.
Okay, so it's 1, 2, 3, 4, 5, 6, 7. 7 4s?
It's 5, it's 15, 6, and then 1.
Okay, so we've got 7 plus 60. So that's 67. Plus 60, well, 67 plus 66 is what?
133.
133 plus 28.
It's 161.
161 divided by 36. Do you happen to know what that is?
Not off the top of my head.
Alright, well, let's see. 161 divided by 36 is 4.5, basically.
4.4722.
Okay.
Alright. So, around 4.5.
So it basically jumped up from 3.5 to 4.5. Now, when I add more dice,
It
so
should-
I take 3 out of 4. Do you think my average is going to be 3 times 4.5? Or 13.4? Do you think it'll be less than or greater than 3 times 4.5? Do you think as you add more dice and you take 1 away, the average value goes up on the dice or down?
I think it'll be a little. It might be up,
I
but
think it'll go up.
I mean, you're not repeating the same process each time.
I'm not talking about the sum. Obviously, when I take the best 2 out of 3, the sum's going to be higher than 4.5. I'm talking about when I take that sum and divide by 2 and the average value on my dice.
Oh, I think that's gonna be less
Why?
because you're only taking 1 away. You're not repeating this process.
Okay.
So since you can only take the worst 1 away, if you get 2 ones, you're gonna be stuck with 1 of them.
Okay.
Oh, yeah. Then it might be less.
All right. Okay, cool. Well, let's go up to the computer and play around a little bit, all right?
All right.
Alright.